Hello, and I'd like to thank you for taking the time to attend this webinar. We hope that you get some value from this session. Some quick housekeeping: this session is being recorded and will be uploaded onto our YouTube channel. And if you have any questions during the presentation, if you could post these into the chat tab, someone will get back to you within 24 hours. Alternatively, you can contact us using contact details that we'll be showing at the end of this presentation. My name is Graham King, and I am the go-to-market lead for data strategy, governance, and advisory here at Agile Solutions, and I'd like to give you a brief overview of the session that you're about to see. I'll give you a quick overview of Agile as an organization, how we help clients with their data, and then I'll hand over to Jeff Jones, who will look in more detail at the architecture to support streaming on Azure, services that can be used for streaming, and some use cases around streaming on Azure, as well as a demo of these functionalities. Wendy Hutton will then give you a demo of streaming data represented in Power BI, and following a quick summary, we'll then close the session, and any other questions will be captured and we'll look to follow up offline. So please keep those questions coming. So a quick overview of Agile Solutions. I'd like to introduce you to Agile and really give you a sense of who we are as an organization. Our mission is to reinvent digital consulting for our clients through business agility, intelligent and disruptive technology, and proven customer value. What does this mean to us? We're really looking at the focus of enablement of our clients' people and processes, embedding agile methodologies and the targeted application of data in order to increase the speed and accuracy of their decision-making capability, and by extension, the business's operational effectiveness and profitability. As you can see, we have a number of cross-industry customer success stories. We've got a proven track record for over 18 years, and we have 70+ data and information management experts. We are based in the UK. We are very customer-centric. One of the things that we're also very proud of is our partner technology aspects, and our industry partnerships with our own insight and experience allows us to more effectively identify opportunities presented by emerging technologies and to target appropriate use cases and applications for those technologies, finding the right job for the right tool. We develop and maintain a focus on a clear business case with measurable and demonstrable benefits, and that really helps us keep our feet on the ground, delivering pragmatic, realistic, and value-driven solutions. Our service offering and our delivery structure is based on our specializations throughout the data lifecycle, and we break this down into 3 focus areas. The first focus area is data strategy, governance, and advisory. And this is where we're looking at the strategy development and planning for data, data governance and the data security framework, architecture and infrastructure design, and really providing the foundations for success for building data management capability within an organization. Moving on from that, we have data platforms and engineering. This builds on that foundation and introduces operational components within that lifecycle. This means things such as designing and creating data repositories, connecting to business systems, and building integration pipelines, configuring those components into data platforms, and expanding the type and format of data available to capture, and then consolidating and bringing structure into the enterprise's data itself. Our last area is visualization, analytics, and insight. And this is leveraging that operational framework and designing processes to help develop insight from that data, producing multiple channels to push that value out to the business. This can include such areas as visualization and business intelligence initiatives, analytics and advanced analytics techniques, often with a customer focus, and the distribution of data down through the business and out to customers and third parties where appropriate. We have a number of services that run across all of these areas, such as delivery assurance, DevOps, data ops, and managed services. And that allows us to engage with clients in a number of different ways using flexible service and delivery models to suit requirements, including rapid project engagements, longer-term program delivery, or full managed service deployments. As I mentioned earlier, with our technology partners are very important to us, and you can see at the bottom the technology partners that we have that run across those 3 areas. What does this then mean for clients overall? So overlaying this onto our data lifecycle, we can help organizations modernize their data. So by migrating to the cloud to take advantage of the ever-increasing and evolving data management and analytics services available there. We can also help customers to manage their data more effectively through the centralization, management, understanding, mastering, and visualization across multi-cloud or hybrid environments. And we also help organizations to monetize that data, the exploitation of that data to competitive advantage through increased revenue and/or operational efficiencies. You can see then how this translates into engagements with our clients. We cover the full spectrum of the data lifecycle with a broad range of clients across multiple industry sectors. This includes public sector, financial services, manufacturing, retail, travel and tourism. And we've provided solutions and delivered engagements for organizations of varying size, from medium to large enterprise companies. And increasingly, we're speaking to smaller organizations as we help them develop data management strategy and build their capability. We've also worked with many of our clients from early on in the life cycle on initial engagement, extending and building on those engagements and progressing through subsequent stages. As I mentioned earlier, drawing on our partners' expertise, partnerships are very important to us here at Agile, and here are a selection of the partner programs that we are proud to be members of. And as you can see, we're across a number of the main players in the cloud area. I would like to now hand over to Jeff Jones, who's then going to take a look more at the architecture within this webinar.
Great, thanks, Graham. My name is Jeff Jones. I'm a lead data engineering consultant here at Agile Solutions. I'll talk you through the a couple of target architectures that are available within streaming ecosystems, as well as talking you through a demonstration of a potential use case for streaming. So to begin with, we'll have a quick look at a typical streaming architecture that we can enable using Azure's platform as a service. On the left, we can see a number of different data sources comprising of everything from traditional structured relational data that you might be familiar with, all the way through to semi and non-structured data such as images, text files, audio files, things like that. Using the resources available to us within Azure, we can consume all of that in one of two broad ways. At the bottom there, you can see we're talking about either near real-time or batch consumption. We can use things like Synapse or Azure Data Factory to consume those in a more traditional ELT/ETL paradigm. But for data that needs to be consumed at real-time or at very low latencies, we have functionality to consume that as a streaming data set in the real-time sort of paradigm. And for that, we can use either IoT Hub or Event Hub. We have elected to go through IoT Hub today. It's more relevant to the use case that we're going to talk about, but there are some core differences between IoT Hub and Event Hub that you need to make design decisions on a use case by use case position. For our interests, IoT Hub is the most appropriate because it allows us very low latency communication and a lot quicker time to live in terms of configuration. So out of IoT Hub, we have two broad paths of data. We have the cold path, which allows us to write data down into our data lake for deep dive analytics and data science purposes. We also have a hot path, which allows us to take data straight from IoT Hub into Stream Analytics, and from Stream Analytics, we can then pipe it out into a myriad of places for real-time consumption, as well as deep dive analytics as well, using Synapse dedicated SQL pools. A lot of the time you want to be able to visualize that output. So we have Power BI as a consumer of those data sets. We'll get into the specifics of that in our demonstration. And then from Power BI, obviously we can generate all sorts of wonderful visualizations and data storytelling outputs for the business. On top of that, we have our governance piece using Azure Purview, which has connectors to all of these services, which allows your data governance functionality to be able to understand the data lineage and the data journey that goes from end to end, right the way from consumption all the way to the presentation layer. So just a brief note on some of the functions that we'll be using within Azure. Azure Stream Analytics is our real-time analytics processing engine. It's a platform as a service that allows us to ingest data from a myriad of sources in real time and pump them out into different outputs based on what we need. Azure Synapse Analytics is a one-stop shop for analytics. It's a limitless, scalable platform that allows us to effectively never leave one screen from consumption, from ingestion all the way through to presentation. Pardon me. IoT Hub is the ingestion point for all of the streaming services that we'll provide, and Power BI is obviously our BI platform that allows us to generate visualizations and outputs for the business. So we'll just hit on a couple of the use cases for streaming. These are some potential situations in which we think that streaming would be appropriate. Obviously, it's not always appropriate for every use case, but there are some where there's real benefit to be found. Tracking visits to a website is traditionally quite a data-intensive process. If it can be configured to output in a streaming messaging system, then that allows you to get a much quicker insight into how your website's being used in real time. That's often a big challenge for e-commerce businesses, where the data comes out of platforms like Google Analytics, which is large nested data that's very difficult to process, and the time to live or time to insights can be quite long there. Streaming would allow you to cut those time to insights right down to almost real time, which is obviously a huge benefit to people that operate in the sort of web space. Monitoring physical assets such as devices within data centers and warehouses is super important. Being able to control or to monitor the situation that's happening physically in real time, super useful. We can detect failures in things like assembly lines or within warehouses, so we can respond to them and get the right people in the right place at the right time very quickly using streaming data. We can also track things geospatially, things like vehicles, anything that's equipped with a GPS sensor. You'll be able to sort of track assets in real time where they are within a physical space. That can obviously be extremely beneficial. Another core use case is in the healthcare sector, where being able to monitor the situation of people as they're undergoing healthcare treatment can obviously be extremely beneficial. Being able to respond to changes quickly and set up automated processes off the back of them, you can imagine that being extremely useful. And another area that's really exciting is allowing machine learning algorithms to consume streaming data sets and to respond quickly using, if you have a big data science function that spent a lot of time developing complex algorithms, being able to unleash those algorithms on streaming data sets can be extremely powerful and unlock some really exciting outputs from that. So with that being said, I'll talk you through our specific use case that we've set up a demo for. In our use case, we are going to be discussing a scenario in which we have a business that has a number of devices. Those devices are fridges, and those devices are streaming data out about their temperature. Now, the journey starts in Azure with IoT Hub. IoT Hub is provisioned within Azure, and it allows us to, it's a central place for us to configure all of our devices in the real world. So we always start at the overview here, and it gives you some information about what we have going on. You can see here that we are having messages pumped into IoT Hub. And within IoT Hub, the first thing we're going to look at is our devices. So before you do anything, you're going to set up a device in IoT Hub. For our purposes, I've created one. I've named it Sarah. And within Sarah, we have lots of configuration here, and this is what we're going to use in our client software. Now, a quick note about how we often see streaming services set up is we'll have a number of devices in the real world, but often you'll find is that those devices will actually send their messages to a central computer that will act as a middleman for those messages. It will aggregate them and batch them out. And this is a much more cost and time effective way, and it lowers your network overhead, and it allows IoT Hub to have one single point of contact for all these messages. So in our use case, we have 5 fridges, and they're all communicating with one producer, and the producer sends messages to IoT Hub. This is once we've configured our device, we have a number of keys here that are going to be extremely useful for us in order to communicate bi-directionally with the device. IoT Hub allows us to communicate both ways. We can send messages to the device, and the device can send messages to us. In our situation, we're just using the unidirectional one where messages are coming from the device. For the purposes of the demo, I've just whipped up a quick Python script that generates a random temperature for one of 5 fridges every half second. You can see here that the actual configuration that I need in order to do this is given to us by IoT Hub. So once your client is configured to be able to communicate with IoT Hub and it's generating the messages, we get a message sent, and then IoT Hub responds with a little message there just to tell the client that it is communicating and it's receiving those messages. From there, we have our IoT Hub. We know that that's now communicating, it's getting those messages and everything's connected, and we like that. So we're going to move over to the next step, which is Stream Analytics. Stream Analytics is the glue that sticks our streaming ecosystem together. Stream Analytics allows us to consume data from a myriad of sources, do potentially quite complicated analytics in real time, and output those the output of those analytics to a myriad of outputs. For our purposes, I'll talk you through the inputs first. So in our Stream Analytics environment, we have configured one IoT hub, and that is configured to communicate and receive all the messages from our IoT hub, and we've configured it to send it through in the JSON serialization format. We can also use Avro as a format as well, which is a slightly lower overhead in terms of size because the schema is built in. As you can see, we have a few options in terms of streaming inputs: IoT Hub, Event Hub, as I've discussed, as well as events out of Gen 2 data lake storage within Azure. The next thing we're going to want to configure is our outputs. As I mentioned before, Stream Analytics allows us to consume from a number of sources and output to a lot of different sources. In our case, there are 3 places I want to send my data. The first place is our dedicated SQL pool. This is going to send every message that we receive and pump it straight into a dedicated SQL pool within Synapse. You can look at the config here, and we've just connected to a SQL pool table that exists. So I created a table and gave it the schema, and now Stream Analytics is populating that table every time it gets a message in real time. This will allow us to perform all sorts of analytics, machine learning, presentation layer stuff, visualization stuff for the historical data. So this will have every record that's ever been generated by the IoT Hub. And serverless SQL pools present themselves to the outside world as normal SQL tables. So if you're familiar with connecting to a SQL table or to a SQL server, then it's no different to connecting this. But the difference is behind it is a massively parallel processing system that allows you to generate, to store data at the big data level, petabyte level, without any real query problems. The second place I want to send my data is to Power BI. Now, Power BI allows us to set up these special data sets called streaming data sets, which Wendy will get into in a little minute. But the really powerful thing about Stream Analytics is that we can configure in our output here a specific, if we have a pre-configured workspace, when I create a new output, all I need to do is give it a name and then populate a table, because Power BI stores a 20,000 event long history for each one of these streaming outputs. We give it a dataset name, and then as soon as this streaming analytics starts up, it will generate those streaming data sets. So we don't need to do anything or provision anything at the Power BI end. It will just appear in our list of data sets that are available for visualization. So if a new fridge were to come online, I would just need to configure out a new Power BI output with the same configuration, just with a new distinct name in the data set. And as soon as that started to consume data, it would appear for our data visualization teams, and they'd be able to start using it straight away. Now, the thing that connects our inputs to our outputs is a query. We can configure that query within Stream Analytics very simply. It's a really standard query language. It's just ANSI SQL with a couple of little extra bits put in. So if you're familiar with basic queries, then you can configure this very, very easily. The first thing we need to do is create a little common table expression. This just allows us one single input for our configuration. Because we have multiple devices sending out multiple device IDs, we just need to aggregate them into this one common table expression. And then from there, we pipe our data into different outputs depending on what we need. So as you saw earlier, I configured a Synapse output for everything. So I've just used select star into Synapse output from all events, which is our CTE. Now, for each one of my Power BI outputs, I actually want to split those out based on the device because we want to see one streaming data set per device. Now, I know we have 5 devices, so I've just created this really simple query: select everything into Power BI output 1, where device ID equals 1. Really simple query. And then we just replicate that for all of our Power BI outputs, one for each one. If there were a 6th device come online, I would just replicate this query and obviously change it into the appropriate output using the appropriate where condition. Now, the third and final output that I want to discuss is an alerting mechanism. So as you can see, I've configured an alert output here that pumps into a function app. Whenever this function app receives a message from Streaming Analytics, it uses some downstream processing to send an email to a pre-configured list of people to let them know that something has happened. You can imagine this being really useful for an exception. For example, in my query, I've configured it so that when the temperature exceeds a pre-existing threshold, for me 6 degrees, then it will send it to the alerts output, and that will trigger an email into the inbox. So now that we have all those systems configured, I'll just quickly go over our SQL dedicated pool. In Synapse, we have this dedicated SQL pool that exists. We can see that in our data tab in our SQL database, and we've got dbo.streamtable. This gives us all of our data, and we can just query that. I've written create rather than select. And we can query that using the built-in query engine and the built-in IDE, and you can see that all the events stretching way back to the 10th are in there, historical, and we could see that those records are being populated in real time, which allows us to do both simultaneously deep dive analytics as well as trend analytics for the near or real-time scenarios. So with that, I'll hand over to Wendy Hutton, who will discuss some of the Power BI outputs and how they can be used to tell engaging data stories.
Thanks, Jeff. So now we have the 5 streaming data sets that automatically appear in the streaming workspace defined by Jeff. I can go ahead and build a real-time dashboard in Power BI. We select New, Dashboard, and give the dashboard a name. After creating the dashboard, I can visualize the data by adding a custom data tile. To add a tile, select Edit and Add a Tile, and select Custom Streaming Data. And select the dataset for my visual. I'm going to select the dataset for Fridge 1. Currently, there are 5 visualization types available. There's card, line chart, clustered bar chart, clustered column chart, and gauge. I'm going to start off by adding a line chart as I want to visualize data changes across a time period. So I'm going to select my axis and add the values to plot. Set the time window to display. This means the range of the data to visualize. The default is 1 minute. For demo purposes, I'm going to set it to the last 5 minutes. As I select valid values, you will see the data starts to display. So in the next window, you can optionally add a title or subtitle. And click Apply to save. I'm going to go ahead and add a card tile visual to visualize the latest temperature value. So I select Edit and add a tile and select Custom Streaming Data and select my dataset. Card is already selected. I'm going to add my field value. I'm going to edit the data label to show the value with 2 decimal places. Okay, I'm going to title my visual. I'm going to give it a subtitle. And click apply. And you can adjust the visuals to suit your needs. You can move them and you can resize them. In the interest of time, I've completed this process across each of the streaming data sets until I've had a real-time view of the temperature of all 5 fridges. And here is the finished dashboard. So we have a dashboard that updates its values continuously as it detects changes in the database, updating the content based on the latest data available. We can, in addition to having a real-time dashboard, combine the real-time visuals with our historical data report based on data using the regular import mode. So here is my Power BI app containing my historical fridge temperature report. And I've created a dashboard where I've pinned a couple of real-time streaming tiles and added context by also pinning visuals containing my historical data. So that concludes my Power BI demo. I'm going to hand over to Graham to provide a summary.
Thank you, Wendy, and thank you, Jeff, both for those really excellent demos. So in summary, I think there are the 3 main areas that really want to pick up on this is, first of all, is pick the right use case for streaming. Streaming is great for some data sources, and you've seen the demo today of how that can be used. You've seen the demo of how that can be brought into Power BI. But because of other latencies, there may be more appropriate and cost-effective solutions. So pick the right use case for that streaming use case that you're looking to use. The other tip that we'd have is start small and build out. Building out a proof of concept is a great way to assess a technology and to provide a more concrete view of those predicted costs. And again, from having done this before, we would recommend that when you are building out a POC, to just keep an eye on the future as well, and always keep in mind how you would scale from a proof of concept to a larger pilot and then on to an MVP type scenario. So keep one eye on the future, but very much start small and build out using that POC to assess the technology. And the last tip is really to understand the value and the business impact. So when you're considering use cases for your analytics, it is important to link the outcome to a business benefit to ensure that you're building that credibility with your senior stakeholders. Ultimately, everything comes back down to that business benefit, and that's really where you're looking to do it, tie the technology and tie the streaming into that business benefit so that you have that credibility with your senior stakeholders, and they can also see the value of this streaming technology in your business. And with that, I'd like to thank you all for attending this webinar. Please keep any questions coming into the chat window. And also, as promised, if you need any answers or any answers to questions, then here are our contact details on the screen. And please feel free to drop any of us a line. And with that, I would like to conclude this webinar and thank you very much.